Hello students, Standard 7. In physics, the revision of Chapter 14, Electric Current and its effects. In the last session we revised about the different symbols used for the components to draw the circuit diagram. We learn about the construction of battery. Also we saw about the circuit and types of circuit, open circuit and the closed circuit. Now today we are going to revise the effect of the electric current. There are mainly three effects of electric current: heating effect of electric current, magnetic effect of electric current, and third is the chemical effect of electric current. In this standard, we are going to learn about only two effects, that are the heating effect and magnetic effect. About the chemical effect you will learn in the next standard, in 8th standard. So first of all, today we are going to revise the heating effect of electric current. For that, first we can have an activity that take an electric bulb, a shell, a switch and connecting wires, and make a simple circuit and switch on. First keep the switch in the off position, then you will see that the bulb will not glow. Now switch on means put the switch in on position for few seconds, like, or maybe for a minute. You will see that when you switch on, the bulb will glow. After 1 minute, switch it off again and touch the bulb again and feel the difference. In the beginning, when the switch was in the off position, the surface of the bulb will have the normal temperature. But after switching on for 1 minute and switch it off again and you touch it, then you will feel that the bulb is little hotter than before. It means that when current is passing through the electric wire, that wire becomes hot, and that is known as the heating effect of electric current. So when, as I told you, when you switch on the bulb or any wire, you keep the, pass the current, then that wire becomes hot. So that effect is known as heating effect of electric current. And therefore, it is advised that we mustn't touch the lighted bulb, because when the bulb is lighted, the element inside is getting hot, and therefore the bulb can be very, very hot and you can burn yourself. Now we saw that the heating effect means the heat is produced while the electric current is passing through it. Now, on which factors, on what factor does the heat produced in a wire depend? So, the heat produced is depending on different factors like the nature of the element, means which wire material, length of the material, and also the thickness of the materials. So that are the three factors, means material, means type of material, nature of material, secondly the length of the material, and thirdly the thickness of the material. That are the factors which effect on the how much heat is produced. So in some of the element more heat is produced, some of the material will have less heat produced. So there can be different again, according to the type of materials used in it. Now here we saw that when we light the bulb and bulb is getting hot, in this situation the heat produced is actually undesirable, because we switch on light only, we switch on the bulb only to get the light. But here the heat is also produced which is undesirable. But some of the appliances that we are using, we really use to produce heat. It means that those appliances are working on the principle of heating effect of electric current. In your houses also you are using few appliances which are working on the heating effect of electricity. For example, an electric iron to press your clothes, to iron your clothes, or the electric heater or the electric stove, etc. The toaster also working on the same principle, that heating effect of electric current. If you have seen an toaster, so a toaster or an electrical appliances like the heater, there is a coil of wire is used in it, and that coil of wire is called an element. So when the current passing through this element is getting red hot and emit the heat, and therefore in the toaster the bread are getting toasted and converting into the toast, and iron becomes hot so we can press our clothes nicely. So in that you can see in some of the appliances the elements are inside. For example, in the iron you cannot see the element that is used, but in the toaster you can see that when you switch on the toaster, after putting the slices of bread in it, the wires inside are getting hot, red. It means that they are getting hot. Similarly, some electric stoves are also such that we can see the coil inside, as shown in the figure here. Here it is the element that is used in the electric iron that you cannot see. We cannot see it, but there is such. So the hot plates, the electric iron, electric toaster, oven, microwave, all these appliances that we are using to produce heat are working on this effect of, means heating effect of electric current. So we discussed about first and second and third questions. Now the CFLs. In the beginning we discussed that when we switch on the electric bulb, then it gives the light, but along with it, it also produces heat. Here it is the wastage of energy, wastage of electric current, because some part of electric current is used to produce the heat which is indesirable. We cannot use that heat. So to save the electricity and save the wastage, we can minimize the wastage by using CFLs in place of the normal electric bulbs. The full form of CFL is compact fluorescent lamp. So these are same like the fluorescent tube light that we use. And these CFLs are saving the power because they are reducing the wastage of the electric current, because they are not getting that much hot, same as the bulb. And you can use that CFLs in our normal bulb holders. And therefore, CFLs are preferred over electric bulbs, because electric bulbs are wasting electricity because they are going very hot. So the CFLs are used in place of that to reduce the wastage. Now, but you have to be careful when you buy these CFLs, because there must be an ISI mark. Actually, on any of the electric appliances you buy, you must look for an ISI mark, Indian Standardized Institute. It means that appliances are tested properly and they are suitable to use in our houses. Otherwise, there can be some accident happen, overloading or the short circuit, etc. Therefore, always buy all the, not only the CFLs, but any electrical appliances you buy, electric kettle or electric geyser or whatever, smallest to smallest thing also, you have to look for the ISI mark on them. Now the another most important appliance or the thing that we are using is an electrical fuse. I think everybody is familiar with the electrical fuse. When the electricity comes in our house, first it will pass through that fuse, then from the meter, and then from the meter it enters our houses. Now this fuse will have a special type of wire which is used to prevent our household appliances. Because sometimes what happens, that the high voltage power is flowing in the wires, and our appliances and our electric circuit is not gonna tolerate that high voltage power. Sometimes due to some reason we get the overload. For example, the insulation of wire is gone off, or two wires come in contact, touching each other, or sometimes, as I told you, excessive current is coming from the wires. In this situation, it can cause overload. And that due to the overload, you can see that is the excessive current. See that there can be some short circuit, and due to short circuit, sometimes the house can catch fire also. So to protect, some protective thing are used in the buildings. That is the electric fuse, which prevents the damage. It means it is a safety instrument. So the safety instrument fuse is almost in all the buildings. It looks like this. You can see that here in this, between those two terminals, we have to tie a special type of wire, which is made from a metal such that it melts when the excessive heat is there. Means low melting point wire is used, like a nichrome wire. So when the high voltage power is there, or any short circuit or any overloading is in our electric circuit, due to the excessive heat, the heating effect of electric current, the wire will get melted because of the high temperature, and it will break the circuit, and that electric current will not flow in our houses, and we can protect our appliances from that short circuit or the overloading, etc. When you replace the broken wire, melted wire with a new wire, then the electric current will flow again. So that is the electric fuses and its importance. Sometimes in some appliances they have their own small, like that type of fuses also available. It can be screwed in it. So sometimes only for the particular appliances also there are some fuses are available. So fuse is a safety device which also works on the heating effect of electric currents. Now the last question we are going on is the MCBs. MCBs. Everybody is now familiar with the MCBs. They are also same like the fuses, but in that the wire is not used. Means wire is not getting melted, but in which when this type of situation happens, like overloading or the short circuit, the switches are getting off themselves, they are tripping. So it is known as MCBs, miniature circuit breakers. So as I told you, they automatically turn off when the high voltage power is flowing or some short circuits are there. They are automatically switching off so that we can save our appliances, and that also must be with ISI marked, otherwise it cannot break the circuit when the high power is there. It will still on, then the power will flow in the circuit and it can damage our electrical appliances. So that MCBs are used like that. I hope everybody is familiar with this MCBs. So when excessive power is there, it itself is automatically switching off, and then when we switch it on again, it can complete the circuit and the power will go in the wires. So as an assignment we discussed all these questions. So you will write down the answers on your own. If any figures is there, like in the fuse there is figure or heater, in that also there is coils, you can CFLs is fine, you don't, but MCB also there is a figure, so you can draw the figure also. Here we are going to finish the session. In the next session we will learn about the other effect, that is the magnetic effect of electric current. Thank you very much.